All right, let's take a look at electrolyte balance. So electrolyte intake, we're going to get our electrolytes from our food, our beverages, and metabolic reactions. Electrolyte output, this can be lost in sweat, feces, and urine, and most of it is lost in urine. So let's look at the regulation of certain ions. So I'm just going to look at 3 different ions here. The first is sodium. So water follows sodium ions, and it's going to have a really big impact upon osmotic pressure. So it controls our extracellular fluid volume and water distribution in our body. So most of our sodium is reabsorbed in the proximal convoluted tubule and also in the loop of Henle. There's a couple of hormones involved here. One is aldosterone. So the other 90% of our sodium reabsorption is caused by aldosterone. So if we have more aldosterone secretion, we're going to have more sodium ion reabsorption that occurs there. So if we have more sodium reabsorption, we're going to have more water reabsorption. So just the reverse is not always true, meaning if we have more water reabsorption, that does not always mean we have more sodium reabsorption. So we are talking about ADH. All right. So angiotensin II causes aldosterone secretion. So next is atrial natriuretic hormone, so ANH. This has kind of the reverse effects of aldosterone. It causes more sodium ions to be excreted from the kidneys, so we also then excrete more water. All right, this is going to have an effect in that it lowers blood pressure. ANH is also a vasodilator, which is also going to lower blood pressure. And ANH secretion inhibits ADH secretion, renin secretion, and also aldosterone. All right, let's look at potassium now. So potassium is our chief intracellular cation, or positive ion within cells. So it is required for neuromuscular functionings and metabolic activities. So even slight changes in potassium ions can alter neuron and muscle activity. All right. So, where one of the things that can occur here is you can disrupt the electrical activity of the heart by offsetting those sodium ion concentrations. Now, looking at the kidney, most of the potassium is reabsorbed, about 85% is, but 15% is lost to urine regardless of need. And so this is one of the problems with people who have diabetes, is because they urinate out large volumes. This can throw off their electrolyte balance pretty easily. So you're going to lose 15% out of your plasma regardless of the need that you have. Okay. So if our blood levels of potassium are low, potassium from our intracellular fluid compartment is lost to the extracellular fluid compartment. And then that gets filtered out in the kidneys, so you can lose even more. If we look at blood plasma, excessive potassium in the blood plasma causes more potassium to be secreted out by our kidneys. Aldosterone also causes an increase in the secretion of potassium. Next, let's look at calcium. Most of our calcium, 99% of our calcium ions, are in calcium phosphate, which is found in bones. Calcium, though, is used for other things. It's used in blood clotting, cell membrane permeability, and neuromuscular excitability. Low calcium ions inhibits neurons and also muscle cells. 98% of the calcium is reabsorbed in our kidneys, and our bone is a reservoir for it. 2 hormones involved in calcium. One is parathyroid hormone, secreted by the parathyroid gland. So low calcium ion levels in our plasma causes parathyroid gland secretions, parathyroid hormone secretion. That's going to activate osteoclasts to break down bone, and it's going to release calcium ions into the blood. So it's also going to cause more absorption of calcium ions in the small intestine, and it causes more reabsorption of calcium ions in the kidneys, and also at the same time the excretion of phosphate ions. What has opposite effects of parathyroid hormone is calcitonin, and calcitonin is secreted by the thyroid gland. So it is secreted when our blood calcium ion levels are high, and it stimulates osteoblasts to make bone, so to take calcium out of the plasma.